For this video, we are here to discuss about IPv4 and on how to determine the type of classes, computations, and other related topics. So if you're interested, please don't skip and do watch the whole video till the end. Thank you. Nowadays, in this rapidly evolving global internet world, we can't skip the importance of IPv4. So what makes IPv4 special? IPv4 stands for Internet Protocol version 4. It is the foundation of communication on the internet. It acts like a unique address system that identifies devices on a network, allowing them to send and receive data packets. So IPv4 has its own parts: network, host, subnet, number, or gate. IPv4 was first described in 1981 by the Internet Engineering Task Force and was later adopted by the Department of Defense of USA in 1982, subnet 1982, ARPANET 1983.
So as a continuation for this video, I will going to show you the different types of class of IP address, and then the range, then the example of IP address. So first, we're going to show the type of class, which is the class A, the class B, the class C, the class D, and the class E. So the class D is we call multicast. Then the class A, it will call the reserve, because the IPv4 is not already maximize the range or the quality of each IP address belong in IPv4. So next is the range. So the class A, we can determine the range of class A by this. Start from 0 to 127. Then class B start for 128 to 181. Then class C start 182 to 223. Then class D start for 224 to 239. Then class D start for 240 to 255. So here is the example for the IP address. So as you can see, the range of class A is 0 to 127. So we can determine to the IP address if what is the type of class. So as you can see, we can determine the class of each IP address by the first octave. So in this IP address, so 10.20, 0.30, 0.40. So we can determine when this first octave, it will belong to the class A, because the range of class A is 0 to 127. Then into class B, 172, the first octave. So we can determine that this IP address is belong to class B, because the range of class B is 128 to 181. The next is the class C. So 192. So this IP address belong to class C because the range is belong to 182 to 223. The next is 239. The 239 is belong to class D because the range is under 224 to 39. The next one is the 225 or 255 rather. Then 255 is belong to 240 to 255, which is the class D or the reserved class. And now I will going to show you the subnet mask of each IP address. So first, the subnet mask for this IP address, which is the class A, so it will start to 255. So this is the subnet mask for the class A IP address. The next is the class B. So the class B will be 255.255.0.0. So this is the subnet mask of this class B IP address. The next is the class C, which is start for 1 and 2. So 255 255, that's 0. So for the class C, the subnet mask will be this one. For the class A, we have only 255, which is the first octet. Then 255 in our class B, which is second octet. Then for the class C, we have 3 octet for the 255. Then now for the class D. So 255, that 255. So as you can see, the subnet mask for the class D is have a 4 octet for 255. But these two class D and E have the same number of subnet mask, which is they are the same 255, then 255. So for this subnet mask, we can determine the network and the host. So for the subnet mask, this is the network, and then this is the host. Then for the class D, this is the network, then this is the host. Then for the class C, this is the network, then this is the host. So we can now determine the subnetting number or the bits for this subnet. So for computing the bits or determining the bits, we can determine the bits using this network for each network in this subnet. Each octet for this subnet or IP address is composed of 4 bytes, which is every byte is composed of 8 bits. So this is our first octet, which is our first byte or 1 byte. So this network will be 8 bits because the first byte in our octet is 8. So let's put /8. Then for the class B, which is we have 2 network. So it will be 16 bits. Then for the class C, we have 3 networks. So it will be 24 bits, as you can see in the previous video. Then for the last 2 class, it will be 32 bits. So if you wonder how I get the bits for this subnet. So now I will show you the binary for this subnet. So first I will show you the first for our first class. So this is the binary. So remember that each octet will compose of 1 byte, which is 8 bits. So 1, 2, 3, 4, 5, 6, 7, 8. 5, 6, 8, 3, 4, 5, 6, 7, 8. Then 1, 2, 3, 4, 5, 6, 7, 8. So this is the binary for this subnet mask. So each network will be automatically convert into 1. Then for the host will be 0. So that's why I put this 8, because if you count this number, it will be 8. So 1, 2, 3, 4, 5, 6, 7, 8. So that's why it will become 8 bits. Then for the class D, we have two networks. That's why we will replace this 0 into 1. 1, 2, 3, 4, 5, 6, 7, 8. Then, if you add this 2 of 8, it will be 16 because 8 plus 8 equals to 16. Then for the third class, which is the class C, we're going to replace again this 4, 0 into 8, 1, 5, 6, 7, 8. So, as you can see, it will become a 24 bits because the tree network for our subnet is composed of 24. You will count the bits using this number 1. All bits that will start in 1 will be counted so that we can determine this bits. So 8 plus 8 equals 16 plus 8 is equal to 24. That's why we can input here 24. Then for the following class, it will be the same. We need to add all the 1 excluding 0. So that's why we can determine the subnetting number or bits. And now, I will going to show you how to compute the IP address into binary. So, I will use class C because class C is our common IP address for this generation. So, example, 192.168.124.0. So, we can compute this one using this following 1, 2, 4, 8, 16, 32, 64, and 128. So 1, 2, 3, 4, 5, 6, 7, 8. So we use 8 bits for this IP address because as you remember, each of 8 is composed of 8 bits. That's why we will use this one. So we can determine this first of 8, 192. So 192, 168, 124, 0. So first, we need to subtract 182 to 128. So I will bring to use 128 because 182 is bigger than 128. So that's why 182 minus 128. So it will be 64. So we are going to put 1 because we use the 128. Then 64. The answer is 64. So that's why we will going to subtract the 64 into this 7 bits to 64, so the result is 0. So that's why we need to put 1 again. Then for the rest bits, we need to put 0. 2, 4, 6, 8. Because if you add 128 plus 64, it will become 182. So for the 168, so we're going to subtract again the 168 minus 128. So 168 minus 128. So 0, then 4. So the result is 40. So we need to put 1 for the 128. Then 64 is greater than 40. So that's why we could not use that. But 32 is smaller than 40. So 32 is below to 40. That's why we need to put 0 for the 64, then 1 for the 32. So we need to subtract 40 minus 32 is equal to 8. So for this bits is 16. So 16 is greater than 8. That's why we need to put 0 again. Then we need to put 1 because for this bits, 8 plus 8 is equal to 0. Then, for the rest bits, we need to put 0 because it will not be used. Because if we add this one, it will be result 168. And now we will proceed to 124. So we will going to use the 64, which is the 7 bits. So 124 minus 64 is equal to 60. So need to put 0, then 1 for 64. Then 60 minus 32 is equal to 28. So we need to put again 1 for the 32. Then 28 minus 16 is equal to 12. So we'll now put again 1 for 16. The next is 12 minus 8 is equal to 4. Then put again 1. Then until we can get the result for this one. 4 minus 4 is equal to 0. If we going to get the result 0, we need to stop subtracting. So we need to put 1 again. Then for the rest 2 bits, so we need to put 0. So for this one, so we need to put only 8, 0. So if you are going to add this two numbers, which is 1, so for 128 plus 64, so it will be 182. Then for this 168, so you need to add 128 plus 32 plus 16. So it will be result 168. Then if we're going to add 64 plus 32 plus 16 plus 8 plus 4, it will be 124. But remember, to get easily the binary for IP address, if you're going to follow this step, you can get the binary easily. So remember, you need to subtract the IP address to the bits for this IP address. And take note, if you are going to compute the IP address to binary for IPv4, you will use 1 to 128. So because each octet for this IP address is composed of 8 bits. That's why we need to use 1 to 128. We need to use the constant number for this IP address because if you use other number, you cannot get the binary for this IP address. So that could be all. I hope you learned something for this video and have a nice day.